Hi and Assalamualaikum. These are our queuing theory project, QMT342, Starbucks Corporation. These are our group members for this assignment. I introduce you Awatif Nazira binti Muhammad Nazri, Nur Nasiha binti Mazuki, Husna binti Muhammad Sa'ad, and lastly, Nurul Fakihah binti Johan.
Firstly, I will explain the introduction of our case study. The location of our case study is at the Starbucks Cafe in Penang. The cafe operating time is from 6 a.m. until 12 a.m. We did our observation from 8:30 p.m. until 9:30 p.m. within 1 hour. At that time, there's only one server. So this is some situation at the Starbucks Cafe in Penang during the observation. Next, I will explain the characteristic of queuing system. There are three major characteristics, which is the first one is arrival, second one is waiting line, and the last one is service facilities. For arrival characteristic at Starbucks Cafe, the size of population is unlimited, or we can call it as infinite, which means the arrival rate is not affected by the numbers of customers in the system. Next, the pattern of arrivals in Starbucks Cafe system, which our lambda is 15 customers per hour, and the behavior of the arrivals are patient customers who will wait in the queue until they are served and will not switch lines. Furthermore, the second characteristic, which is waiting line characteristic, the length of line is unlimited. For queue discipline of the waiting line, priority rule is first in, first out. It is most frequently assumed that the customers are served on a first-come, first-served basis. This is commonly referred to as FIFO system.
Next is service facility characteristics. The configuration of the service system. First, the number of channels. In our study, the number of channels is single channel system and the number of phases is single phase system. The pattern of service times are assumption for service times follows the exponential distribution, and in our study, there are 15 customers per hour.
Next, 2.4 Basic Queuing System Configurations. We want to figure out the type of queuing system used for Starbucks. Service systems are classified in terms of the number of channels or servers and the number of phases or service stops. From our observation, the basic queuing system configuration is single channel system with one server is quite common. Besides, in a single phase system, the customer receives service from just one server. The customer will arrive and make some purchases. After that, they will queue to make the payment. The cashier will serve the customer. In this figure, the customer will arrive and queue to make payment while they will serve by the service facility, which is the cashier. After that, they will depart after service. This is the picture of queuing system in Starbucks. The customer queue patiently to order and make payment. There only one counter serve the customers.
Move to characteristics of the selected queuing system. Our arrival rate lambda equal to 15 customer per hour and service rate mu equal to 20 customer per hour. Firstly, the average number of customers or units in the system waiting in queue and being served. L equal to lambda over mu minus lambda equal to 15 over 20 minus 15. The answer is 3 customer per hour. Next, the average number of customers in the queue. LQ equals to lambda power of 2 divided with mu times mu minus lambda. The answer is 2.25 equal to 3 customer per hour. Next, the average time a customer spends in the system, total time in queue and counter. W equal to 1 over mu minus lambda equal 1 over 20 minus 15, and the answer 0.2 hour or 12 minutes. Next, the average time a customer spends waiting in the queue. WQ equal to lambda over mu times mu minus lambda equal 15 over 20 times 20 minus 15. And the answer 0.15 hour or 9 minutes. For the utilization factor for the system, that is the probability that the service facility is being used. Rho equal lambda over mu equal 15 over 20 equal to 0.75. Lastly, percent idle time, PO, 1 minus rho equal to 1 minus lambda over mu equal 1 minus 15 over 20, and the answer 0.25. Then 0.25 times 100 is 25%.
Last but not least, conclusion. Give comment on the number of servers provided and the customer's waiting time. Is the number of server provided adequate? Yes, it is, because service rate are more than arrival rate of customers. Is the customers are happy with the waiting time? Yes, they are happy because no need to wait too long time to be served. Next, describe what you have learned from doing the project. If mu are more larger than lambda, it will show us that the servers provided are enough to serve customers at a fast rate. But if lambda are larger than mu, the server cannot handle too many customers. This will make waiting time increase because of poor server.
That's all from us. Thank you for watching.